students, we are back with another lesson. In this lesson, we'll solve some numerical on combination of lengths. Now, before we start our lesson, let us revise combination of lengths. In combination of lengths, we have done, let's suppose if your two lenses are placed in contact with each other. Okay, it doesn't matter whether it is a convex lens or it is a concave lens. Fine. If you have two lenses which are placed in contact with each other and coaxially, means they are placed along the same axis, that means along the same line, then in that case the focal length can be written as 1 by f equals to 1 by f1 plus 1 by f2. F1 is the focal length for the first lens L1 and f2 is your focal length of your second lens L2. Fine. Similarly, the power of lens can be written as P equals to P1 plus P2. Fine. Now, using this concept, we'll solve some numericals. Fine. So here is our first question. The first question states, what is the focal length of combination of convex lens of focal length 30 centimeter and a concave lens of focal length 20 centimeter? Is the system a converging or a diverging lens? Ignore the thickness of the lens. Fine. Now, in this question, they have first asked us to calculate what is the focal length of the combination of lens. Right. Now, after we know what we have to find, now what are the hints given in the question? Now, the first hint is given is that what kind of lens you have? It is a convex lens. And what is the focal length of that convex lens? 30 centimeter. Next, you have a, if you have this one, what kind of lens is your second lens? It is a concave lens, and the second lens has a focal length of 20 centimeter. Fine. Now, using this details, we can find the focal length of the combination. Now, after finding the focal length of the combination of lens, we have to determine whether the lens is converging or a diverging lens. Fine. Okay. So first, let us write down. Let's solve the first part of the question. Okay. First, let's find the focal length of this one. Okay. Now, first, let me write down solution. Okay. So here, the focal length of the first lens is how much? F1 equals to, in magnitude, number wise, it is 30 centimeter. Right. Now, what kind of lens is your first lens? It is a concave lens. Fine. So let us draw a concave lens. Fine. This is your concave lens. Okay. Now, always remember, concave lens are what kind of lens? It is a converging lens or a diverging lens? It is a converging lens. Why is it a converging lens? Because if a light comes, okay, it strikes the surface. After diffraction, it converges to a particular point. Fine. It converges the light at this point. So what kind of lens you have? You have a converging lens. Right? Fine. So this is a converging lens. Okay. Now, after this, they have given that you have a second lens. Your second lens is what kind of lens? It is a concave lens. Okay. Fine. The second lens is your concave lens. Okay. Your concave lens is what kind of lens? It is a diverging lens. Why it is a diverging lens? Because if you remember, suppose this is your concave lens. Okay. Now, when a light falls on this concave lens, okay, what happens? After diffraction, the light moves away. Okay, it bends away from the normal. If it bends away from the normal, it seems like it diverging from this point. Yeah, it is diverging from this particular point. In that case, what kind of lens you will have? You will have a diverging lens. So your concave lens is a diverging lens. Okay, apart from this one, one more important thing. Suppose this is your concave lens. This is the principal axis. This is the light. After diffraction, it goes and strikes here. Right. Now look here carefully. For your concave lens, sorry, for your convex lens, this is the focal length. Right. Whereas for your concave lens, this is the focal length. Right. And you know, the light moves from left to the right direction. Right. So now look at this one. In which case your focal length will be positive? The focal length will be positive for your convex lens. Fine. I'll write down here F is positive. And it will be negative for which lens? It will be negative for your concave lens since it is measured in the direction opposite to the incident line. So here your F is negative. Fine. Okay, so let me just move this one to the other part. Fine. Now, as stated in the question, you can ignore the thickness. Okay, this thickness doesn't matter. Okay, fine. So okay, first let us write down this one. Okay, so f1 corresponds to the focal length of your convex lens, and it will be positive or negative. It will be positive. Next is your f2 corresponds to the focal length of your second lens, which is your concave lens, and it will be positive or negative. Negative. And how much it is given in the question? 20 centimeter. Fine, so I write down 20 centimeter here. Fine. Now they have asked us to calculate the focal length of the combination. So the focal length of combination is given by one upon f equals to 1 upon f1 plus 1 upon f2. Fine. So the combination focal length f 1 by f equals to, okay, so how much is f1? F1 is 30 centimeters. I'll substitute 1 upon 30 plus 1 upon f2. F2 is how much? Minus 20 centimeter. So I'll substitute minus 20 here. Fine. Now, what will happen to this negative and positive sign? They will get cancelled and it will become plus. Okay. So 1 by 30 minus, sorry, plus and minus will become minus, and I'll have 1 by 30 minus 1 by 20. Fine. Now to solve this one, it's simple. You can take the LCM of this one. So 1 upon f equals to LCM of 30 and 20 is how much? 60. Fine. If this one is 60, then this one will become 20. And there is a negative sign. So write this negative sign minus. This is 6, denominator 60, then the numerator will be 30. Fine. Now what is 20 minus 30? 20 minus 30 equals to minus 10. Fine. So I'll write down minus 10. Now how much is minus 10 divided by 60? 10 ones are 10, 10 6 are 60. Fine. So your focal length can be written as 1 upon f equals to minus 1 upon 6. Now if I take the reciprocal, okay, I'll send this one to the up, or I can also do one thing. I can do the cross multiplication. Fine. So after cross multiplication, your focal length f equals to minus 6. And in which system we are measuring? CGS, centimeter. So I'll write down centimeter. Fine. Okay, wait just a minute. I made some calculation error at this point. Okay, let me just correct this one. So here the LCM is 60, right? LCM is 60. So 30 times 2 equals to 60, right? Not 20. So I'll write down 2 here. Fine. Next, put a negative sign, and 20 times 3 equals to 60. So here should be 3. Okay, I've made this mistake. Okay, please correct this one. Now 2 minus 3 will be how much? It will be minus 1. So instead 2 minus 3, I can write down here minus 1. Fine. Now on this case, I have to make the correction. On the denominator, I have 60. Fine. The denominator is 60, and if I do the cross multiplication, then f equals to minus 60 centimeter. Fine. Okay, so please make this correction. Now we have found out the focal length. How much is the focal length of the combination of this lenses? 60 centimeter. Okay, minus 60 centimeter. Now if it has a negative one, okay, if it is a negative, then the system acts like a converging or a diverging lens. Negative focal length means it is a diverging lens. Fine. So I'll just write down here diverging lens so that you don't get confused later. And if it is positive, focal length is positive, then in that case you have a converging lens. Fine. So since your focal length is negative, means what kind of system you have? You have a diverging lens. Okay, so what is the basic physical meaning? The basic meaning is that instead of having two lenses, your lens L1 and your lens L2, where L1 has a focal length of plus 30 centimeter and L2 has a focal length of minus 20 centimeter. Instead of having this two lens, what you can do is you can simply replace them with another diverging lens. Okay, that means your concave lens. Okay, instead of using two lens, you can replace it with a single lens. Okay, this single lens is known as your equivalent lens. And how much should be the focal length of this equivalent lens? It will be minus 60. That means somewhere here. Right? Somewhere here. Fine. So let me write the conclusion statement. If focal length is minus 60 centimeter, so the negative value of f indicates that the combination behaves as diverging lens. Fine. Okay, so if you have any confusion from this problem, okay, please don't hesitate to ask. I will re-explain it to you again. Fine. So now let's move to our next problem. Okay. Now your next problem is quite similar to your previous problem. Okay. The next problem is quite similar to your previous problem. In this case also, see, this is a plus 10 centimeter. That means what kind of lens will it be? It will be a concave. Sorry, this will be a convex. Okay, plus 10 centimeter means convex. Minus 5 centimeter means it will be a concave lens. Okay, fine. So you can find out the focal length. Okay, to find out the focal length, you'll use which formula? 1 upon f equals to 1 by f1 plus 1 upon f2. Right. Okay. So you'll use this formula to calculate the focal length. Now, listen very carefully. Here they have also asked you to calculate the power of lens. Okay. Now, if you remember, the power of lens is measured in diopter. Okay. And what does diopter means? It is inverse of a meter. Inverse of a meter. Then which system is this one? MKS system. Fine. Meter, kilogram, second. Whereas your focal length, if you see properly, they are given in CGS system, centimeter, gram, second. So what you have to do, you have to convert your CGS before doing the calculation. What you will do, first you will convert the CGS into meter. Fine. Okay. So if you convert your 10 centimeter from CGS to MKS, your 10 centimeter will become how much? It will become 10 divided by 100. It will be 0.1 meter. Fine. And if you convert your minus 5 centimeter to your MKS system, in that case, 5 divided by 100 is how much? 1 by 20. 1 by 20 is how much? It will be 0.05 meter. Fine. So if you convert your 10 to meter, it will be 0.1 meter. And if you convert your minus 5 to meter, it will be how much? It will be 0.05 meter. Fine. Now these two units are in your MK system. Right. So first what you will do, first you convert 10 to your, sorry, you 10 to your MK system, minus 5 centimeter to MK system. After you are done with this one, then you calculate the focal length. Fine. After calculating this one, then you will first calculate the focal length. After calculating your f, then you will calculate the power of the lens. Fine. Okay. Or we have. let me just do the initial part for you guys. So first, what you have to do, solution here, f1 equals to plus 10 centimeter. If you convert it into MKS, it will be 0.1 meter. Next is your f2. f2 equals to minus 5 centimeter. So if you convert minus 5, it will be 0.05 meter. Fine. Okay. So after this, you calculate the focal length, then you calculate the power of combination. Okay. Power of combination, to calculate the power of combination, there are two methods. Okay. The first one is, first you calculate the combined focal length. After calculating the combined focal length, power of lens equals to 1 upon f. Fine. And the other method is, you can use f1 and f2. In that case, the power of lens equals to 1 upon f1 plus 1 upon f2. Okay, these are the two methods to calculate the power of lens. So what you can do is, you can use this method. Okay, use this method to calculate the power of lens. Okay, see, you can use this method also. Okay, but I'll prefer you to stick with this method. Okay, because what happens, like during exam times, okay, if you have by chance calculated wrong focal length, then your power of lens will be also wrong, right? But if you use this formula, okay, if you use this formula, there are less chance of making the errors. Fine. So I'll suggest you to rather stick to this formula. Fine. Okay, so you can take this question as your homework. Now let's move on to our next question. Fine. Now this is your next question. In this question, find the position of the image formed by the lens combination given in the figure. Okay. Now this example is important. Okay, why this example is important? Now here you can see, they have given you three lenses. Okay. So in this case, this is a double convex lens. This is a plano concave lens, and again you have a double convex or your biconvex lens. Fine. Biconvex, plano concave, biconvex. Now, if you look carefully in this figure, now tell me, are the three lenses in contact? The answer is no. If the lenses are not in contact, then how we will solve this problem? Okay. So in all the previous examples which we have done, in that cases your lenses were in contact, but this time your lenses are not in contact. So how we will solve this one? So to solve this one, first what you will do, consider your first lens, your biconvex lens. Okay. So I'll write down for first lens. Okay. Fine. So consider your first biconvex lens. Okay. Now, as you can see in this picture, this is your object O. Okay. This object is placed at a distance of how much? It is placed at a distance of 30 centimeter. So this is your object distance. Okay. To avoid confusion, let us write U1. So here, what happens for your first lens? U1 equals to minus 30 centimeter. Right? Okay. So they have given you the focal length of this convex lens. How much is the focal length? The focal length is 10 centimeter. Okay. Focal length is plus 10 centimeter. So I write down F1 equals to plus 10 centimeter. Now you can use your thin lens formula. According to thin lens formula, 1 upon image distance V1 minus 1 upon your object distance U1 equals to 1 upon your focal length F1. Now let us substitute the values here. Okay, we will substitute the values in order to calculate your image distance. Okay, so let 1 by V1 be 1 by V1. Yeah, object distance, how much is U1? U1 is minus 30 centimeter. Fine. So minus 30 and minus will become plus. So you'll have 30 equals to focal length is how much? 1 upon 10. Fine. Now I can take this plus 1 by 30 on the other side. If I take this to the other side, what will become? Plus will become minus. Fine. So I have minus 1 upon 30. Now again, using the LCM method, so I'll have in the denominator 30, right? And in the numerator, I have 1 minus, okay, this one will become 3, okay, 3 minus 1. So 3 minus 1 is again how much? It is 2. So I'll write down 2 here. Fine. Now I can cancel this 2. 2 ones are 2. 15 times 2 equals to 30. Fine. So how much is 1 upon V1? 1 upon V1 equals to 1 by 50. Fine. Now again, by cross multiplication or by taking the reciprocal, my image distance V1 can be written as plus 15 centimeter. Right? So V1 is plus 15 centimeter. That means the light starting from this point will go and strikes this point. Okay. So what will happen? The light after refraction will pass through the focal length. Okay. And it will, okay, just a minute. Right. So this is where the image will be formed. Okay. At this point, let us consider one more ray. Okay. If there is a light, then okay. So this is where the images form. Now your image distance, this is V1. Fine. This is your image V1. Okay. So here is done for your first lens. Now for your second lens, okay, for your plano convex lens, okay, what happens that this image form, the real image form by your first lens, by this lens, okay, this real image will act as a virtual object for your second lens. Okay, so let me just write down here. The image form, let me first write down for second lens. The image formed by the first lens lens serves as object for second lens, as object for second lens. Fine. So now this one will act as a object for your second lens. Okay, so let me just draw this one here. Okay, so now if you look carefully, there is a distance of 5 centimeter in front. Okay, so what will happen is that, so if this is your first lens, the image is formed somewhere at how much? 15 centimeter at this point. Fine. Now in this case, what happens? For the second lens, the object distance u2 equals to how much? See, this total length is how much? 15 centimeter. So this small length will be, see, there is a distance. Okay, this distance is how much? 5 centimeter. So I'll write down 5 centimeter here. This distance is 10 centimeter. So u2 should be how much? U2 will be your 10 minus 5. Okay, any confusion with this one? See, the first lens forms the image at not 15. Okay, it forms the image lens at 15 centimeter. Okay, this one forms at 15 centimeter. Then the object will be 15 minus 5 equals to 10 centimeter. Right? Okay. So yeah, I can write down. Or so, do you have any confusion how the object distance is 10 centimeter in this case? If you have any confusion, please don't hesitate to ask. I'll re-explain it to you again. Fine. If you still have confusion, look carefully. Okay. In this case, how much is V1? V1 is 15 centimeter. Right. Now this image acts as an object for your second lens. Now your second lens is placed 5 centimeter in front of the first lens. So if it is placed 5 centimeter in front, what happens? You have to eliminate this 5 centimeter from this actual distance. So if you remove this 5 centimeter, then how much you'll be left with? This length. This length is the object distance U2 for your second lens. And it is how much? 10 centimeter. Fine. So let me rub this one and write again. So in this case, for your second lens, okay, let me just draw your second lens. This is your second lens. Okay, for your second lens, this is your object, right? This one is your object. Then right, for this case, the object distance is u2, right? And the focal length for your second lens is how much? F2 equals to minus 10, right? The focal length is minus 10. Okay, now look, consider the first ray, it moves in this direction. After refraction, it moves away from the normal. Whereas your second ray, which passes through the optical center, it passes in this direction. Now let us see from this picture, you can clearly see that the image will be formed somewhere at very far away. Okay, can you see, are these rays intersecting at any point? No, that means your rays will be, or your rays will intersect at infinity. That means your image will be formed at infinity. Fine. So let's see. So in this case, the object distance, okay, for second lens, your object distance u2 equals to 15 minus 5. Okay, this will give me 10 centimeter, right? And we have to calculate the image formed by the second lens. Okay, the focal length f2 equals to minus 10 centimeter, right? Now again, by using thin lens formula, 1 upon f2 equals to 1 upon v2 minus 1 by u2, right? Substitute u2 is how much? Plus 10 centimeter. Okay, since it is in the direction of the incident light. So 1, and focal length is how much? It is minus 10. Can you see, this point will be the focal length. So here I'll write minus 10 centimeter equals to 1 upon V2 minus 1 upon 10. Right. Now, if you look carefully, this 1 by 10 minus, if it goes to the other side, what will happen? So I can write down 1 by V2 equals to, I have already minus 1 by 10. Okay, on the left hand side, I have minus 1 by 10. If I send this minus 1 by 10 from right hand side to the left hand side, what I'll get? I will get a plus 1 by 10. Fine. So these two terms will cancel each other. If these two terms cancel each other, in that case, this one will be 0. So V2 equals to 0. Now, okay. So 1 upon V2 equals to 0. So if I take the reciprocal of this one, so in that case, what happens? V2 equals to infinite. Okay. Why? Since 1 upon 0 equals to infinity. Fine. So for your second lens, the image will be formed at infinity, which we can clearly see from this picture. Okay. So the image formed at infinity will act as an object for your third lens. Okay. This one, the third lens, which has a focal length of 30 centimeter. Right. So let me draw the third lens first. Okay. So first let's write down for third lens. The image formed at infinity by second lens will act as object or I'll say virtual object. Okay, will act as, or just simply write down object, will act as object for third lens. Fine. So let me just draw the third lens here. So your third lens is a biconvex lens. Fine. And this is the principal. Fine. So what happens for the third lens? The image formed at infinity. Okay, the rays will start to move from infinity, and then what will happen after refraction? It should pass through the focus. Now in this case, the focus for this third lens is how much? It is 30 centimeter. Okay, so I'll just write down 30 centimeter. Fine. Okay, so a ray which starts from infinity after diffraction should pass through the focus, and this length is how much? It is 30 centimeter. Fine. So let me write down for your second case. Okay, in your second case, how much will be u3? u3 equals to v2, and v2 equals to how much? Infinity. Fine. So instead of writing all of this, I can simply write u3. Your object is placed at infinity. Fine. And then you have to find your p3. The focal length is given how much? It is plus 30 centimeter. Fine. So now use your thin lens formula. 1 upon f3 equals to 1 upon v3 minus 1 upon u3. Now in this case, your f3 is 30 equals to 1 upon v3, keep it like this, minus 1 upon u3. u3 is infinity. Fine. Now note, your 1 upon infinite equals to 0. So this term can be ignored. This will be simply 0. So I have 1 upon v3 equals to 1 by 30. Fine. Now I can take the reciprocal or I can do the cross multiplication. So in that case, v3 equals to how much? It will be 30 centimeter. Fine. So the final image is from 30 centimeter to the right of the third lens. Okay, why to the right? Because since it is positive, that means in the direction of the incident light, which is right. Right. So your final image is formed at a distance of 30 centimeter. That means if you have this three lens, okay, suppose you have this three lens, right? So what will happen? The image will also be formed at the equidistance from all these three lenses, somewhere at this one, okay? And at what distance will it be formed? It will be formed at a distance of 30 centimeter from this third lens, fine? So your object O, so this object O forms a final image at a distance of 30 centimeter, fine? So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.